Hello, biologists. So now's the time we get to start doing exciting things with our model, which means one, start making it a little more realistic, and two, start testing it out. So I'm going to share my screen here, and I'm going to go to the lab manual. Okay, so I'm on page S37 of the lab manual. And it tells us that we now have a model in which we can explore how allele frequencies behave and change from generation to generation. So what can we change about our model? If we change something, does that change, what does that change tell you about the alleles behave? That's one thing we can do with our models. Do alleles behave the same way if you make a particular variable more extreme or less extreme? That's another thing we can test with our model. How about no matter what the population size is? Okay, so we're gonna start doing some of these things to our model, and I want you to follow along with me and do the same thing to your model. So I'm going to go to my model. Oh, I didn't plan this very well, did I? I don't know where my outlook. Okay, I'm gonna go to new tab. I'm gonna open up my Hardy Weinberg model Excel sheet that I keep in Office 365. Once I get it open, sorry, I should have done this before I hit record. I'm gonna open this in the desktop app just because it makes everything a little bit bigger for me. It gives me a little more space. So I'm gonna click open on desktop app. Open Excel. Okay, and now just a sec, I need to, as soon as it opens, I need to switch my share. There's a fly and a spider on my computer screen. That was fast. That's what I get for coming outside. The fly, I'm not surprised. The spider, I'm a little surprised. Like black with yellow stripes on it. It's kind of cool looking. Okay, so here I am. New share. I'm now sharing with you my Excel. Okay, so here is my spreadsheet as it was yesterday, or whenever you last watched the last video, or wherever you are last time. And so I had my P and my Q, and I had my gametes that were generated using a random number. Okay, I don't like spiders. Using my random number generator, and they became zygotes, and I used this if function here to tell me if the zygotes were AA, AB, or BB, and then I added them together, and I used that to calculate my new P's and Q's and to make this fancy graph. And every time I hit F9, it all changes. Okay, I'm gonna, wait, why didn't my P change? Okay, there good. Okay, so remember my initial P was set at 0.6. And when I hit F9 this time, my P at the end of this generation is 0.46. And now it's 0.65, and now it's 0.59. Now it's 0.625. So I'm seeing a fair amount of variability in my P. And I think one reason for this, because Hardy Weinberg would predict that I would expect my P to be the same at the end. I would expect it not to change, right? But it is changing. I think the reason for this is that I don't have enough individuals in my population. I only have 16. That's not very many. So look at that. So I'm going to make my population bigger. And the way I'm going to do this is I'm going to right click, and I'm going to click insert. So I'm sorry, I'm right here on the number. I just chose one of these numbers between 5 and 20. And I'm going to right click on it and click insert. Okay, so that gave me a blank cell, and I'm going to come on. I'm going to highlight all 6 of these. Mouse isn't working. Okay, I'm going to highlight all 6 of these rows, grab them by the green corner on the bottom, and bam, now I have 17 individuals in my population. That's not very much bigger. I want to go bigger. So I'm going to right click here, and I'm going to do insert. I highlighted a whole bunch, inserting a whole bunch. Oh, why is my, fell down the stairs with my computer and dropped it, and now my mouse is being extra funky and I'm outside, so my real mouse, oh, maybe my real mouse will work. Okay, so now I'm up to what? I started on 5 and I'm at 32, so almost 30 individuals. And I just want to make sure everything's working okay. So this is still giving me the sum of the whole row. And so these guys are still giving me the sum of the whole row. Kind of weird, I only have one. Make sure that doesn't happen again. Okay, now I have 3, that makes me feel better. Okay, these are still adding up and this is still looking good. Okay, I'm gonna make it a little bit bigger. I'm gonna just highlight between the 9 and the 26. I'm just avoiding the top and the bottom because sometimes that messes up my formulas. But as long as I just play in the middle, it should be fine. So I'm gonna go insert. I'm gonna be real crazy. I'm gonna insert 3 times. I know. Wild. Okay. And I'm gonna highlight this row. I swear to God, that spider's on my, Okay, and now I'm gonna grab it in the corner and drag it down. Okay, until I meet right there. Okay, how's this look? Is everything still working? It looks like I'm up to 83-ish individuals. There's a lot of wildlife out here. A lot of bugs. Okay. And when I hit F9, things are changing. Look at my P's, 0.59, 0.60, 0.63, 0.56, 0.64. So my P's are staying a lot closer to 0.6 where I would expect them to be. I feel like I'm more within Hardy Weinberg equilibrium based on my population size. I'm gonna do it one more time. Okay, I'm just gonna grab this chunk right here, insert, and then doing it now. So this is one thing I can ask my spreadsheet. I can test my spreadsheet. How many generations, not in generation, how many individuals do I need in my population to always have the same, to have my P remain fairly constant? And it's never going to be exactly constant because I have my random number generator in there. But how many do I need to get it within like 0.01, like 1%? I'm still not there, 0.52, 0.62, 0.56, but it's closer. And look, you can see the little bars on my bar graph are jumping around less. I always have most ABs, some AA, and less BBs. So I'm up to approximately 105 individuals. I think I started on row 3-ish or something, and I'm at row 108 there. So I'm going to call that good. Make yours as big or as little as seems appropriate for you. You have to go back and rewatch this, go back and rewatch, pause. But just do like I did, do a quick common sense, make sure that you are summing all the way from the top to the bottom. Mine goes from H5 to H108. Yours may vary. This one's going to go from I5 to I108, from J5 to J108. This one's still going to refer to those cells there. Sometimes the formulas just get messed up a little bit when you start doing this stuff. Okay. Good, everything looks good. Okay, and now I'm curious, what if happens that I make my A like 0.95? Do I get rid of my B's? Look at that, I got rid of my B's, not a single one, 0. But I still have ABs, right? So I'm kind of curious if, oh, I still have some B's there. No B's, 1 BB. So I'm curious, how many generations would the B alleles ever go away entirely? If so, how many generations would it take? So in order to answer that question, I need to add more generations to my graph. Good news, we don't need to redo everything that we just did, okay? We can largely copy and paste. The only thing is, my new generation is going to be based on this P and this Q instead of the one in the upper left-hand corner, because I want to have their babies set up the next generation. So I am going to go up to the tippy top here, and I'm going to label this in really big letters, because sometimes it can get a little disorienting. So I'm going to up my size, changing font size a little too extreme here. Okay, big. I'm going to label this one right here, generation 1. Didn't mean to be so shouty. Also, I want it on the left, not in the middle. Okay, so now I'm going to leave the space right here, and I'm going to make this generation 2. Okay. So I'm going to copy and paste this all over right here. Control C and then Control V. Something went wrong. Everything's B's. Oh, wait, I'm going to put this back to 0.6. Okay, something went wrong. And what went wrong is that it's pulling. So here, remember the A did the random number generator and compared it to cell D2. So my new formula, when I copied and pasted it, it's trying to compare it to cell K2 because that's like in the same spot. I don't want to compare it to K2. I want to compare it to my P down here. And my P down here is in cell H116. So where mine says K2, I'm going to replace that with H116. Okay. So now I can double click on there and make sure I hit the right spot because it'll be in this nice little blue box down here, and it is. So now my random number generator is comparing it to that cell H16, which was my P from the previous generation, at the end of the previous generation. And if the number is less than the value in H16, it'll give me an A, and if not, it'll give me a B. Okay, that looks fantastic. Now B, I need to do the same thing. Right now it's also referring to K2, so I also need to make it refer to H116. Yours numbers may be different. That is totally okay, as long as you have it referring to that P. Okay, same thing. If my P is greater than or equal to, if my random number is less than or equal to my P, then it'll put it in A, and if not, it'll put in a B. And this is an AA, an A and an A, so my zygote is an AA, and so it counted everything correctly. Now, hopefully, let's drag this down. Okay, and it seems to be working just fine. I'm clicking here and it's still referring to H116. I'm still seeing a healthy distribution of AAs, ABs, and BBs. So I'm going to drag this all the way down. Boom, it's right there. I'm going to have this generation have the exact same number of individuals in it as my last generation did. Okay, so there's my generation 2. I just copied and pasted this top row from my generation 1. I updated my P, or the cell that my P was, to refer to the one at the bottom of generation 1. And then I just drug it down, and bam, I just made approximately 105 more babies. Okay, now again, I don't want to redo all that math. I'm just going to copy and paste this. So I'm going to grab this whole thing right here, Control C, put it right here, Control V. Okay, now let's make sure it worked. Is this referring to? Yep, it's referring to 05 to 0108. Oh, I need my underlines. Add those back in with my border. Okay, this should be referring to P5 to P108, and it is. And this should be referring to Q5 to Q108. Perfect. Okay, and then my A should be something based on here. 2 for every AA and 1 for every AB. And these should be 2 for every BB and 1 for every AB. Good. And then this should be the A's over the A's plus the B's. Good. And this should be the B's over the A plus the B's. Perfect. Okay, everything looks fantastic. So that went a lot faster than the first generation, right? Our first generation took like us an hour to put together, and that took us like 30 seconds. Okay, and if I want to get real fancy, I can even copy and paste my graph. Okay, I'm going to do Control C, Control V, and then I'm going to right click on my graph, and I'm going to select data. And all I'm going to do is edit and tell it, instead of referring to H105 to J105, I'm going to delete that. That's my series values. And I'm just going to highlight these ones. O105 to Q105. Okay. There we go. And I'm going to change these names so I know what my graphs are talking about. In second generation. Okay. So I started with an initial P of 0.6. At the end of my first generation, my P was 0.57. At the end of my second generation, my P was 0.55. Okay, and now I have graphs to match all that. See how much faster it was after the first one? This is the power of Excel. Like, yeah, it took us a lot of work to set up that first generation, but now to set up my second, third generations, literally all I have to do is copy and paste. And the fantastic thing is, since generation 2 is already focused down here, I don't even have to go back and change everything like I did for generation 1. I'm just literally going to highlight this whole business right here, Control C, Control V, change the word to generate from generation 2 to generation 3. Bam. Make sure this is working, right? This is referring to O116. Is that what I want? Yeah, that's what I want. Okay. Make sure that this is referring to O116. Yep, exactly. Okay. At the end of this, my P is 0.58. Okay. Oh, it didn't catch in my graph. I have to remake my graph, but that was easy peasy. That was just copy pasting. Okay. I want you to make yours be at least 5 generations long. Okay. So just like we just did. Once you have generation 2 set up healthfully, you can just copy paste for generation 3. I'm going to rename this to generation 4 and then copy paste to make generation 5. Isn't that amazing? This amazes me. I love Excel. Okay, generation 4, generation 5. Look at that. And now I can see how my p-values change over 5 generations. Look, I started out with, in this run, right, because it's going to change every time, I started with 0.6, 0.64, 0.64, 0.66, 0.68, 0.74. Interesting. Okay. So now this is a spreadsheet I can start asking some interesting questions. That's what we will do in our next video. For today, make sure that your spreadsheet does like mine does, where it has a bunch of individuals in each generation. I recommend somewhere around 100. If you're feeling ambitious, make it 1,000. You could. It wouldn't be that much work. I wonder how high you can make it. How far down does Excel go? It goes a long ways. I'm just updating my 3rd generation graph here real quick. And then make it go for at least 5 generations. Depending on the real scientific question you're going to ask your graph, you may want to make it even bigger than this. But this is a good start for now, and that's something that you can change later. Okay. So let me know if you have any questions about this. And tomorrow we'll start working on the next part. All right. Share. All right. I hope you're doing well.